Hi everyone, now we are going to discuss about bus-based computer systems. First, let us discuss about what is bus. Bus is a mechanism by which CPU communicates with memory and devices. A bus is at a minimum a collection of wires, but it also defines a protocol by which the CPU, memory and devices communicate. One of the major roles of the bus is to provide an interface to memory. Of course, input-output device also connect to the bus. Based on understanding of the bus, we study the characteristics of memory components and also focusing on DME. So, here, now these are all the bus-based computer components. It includes buses. It includes low speed bus and high speed bus. Depending upon the device speed, we can use the bus and the memory devices and input output devices. The input output devices includes serial links, timers and counters, keyboards, displays, analog input and output. The CPU bus. Bus allows CPU, memory and devices to communicate and act as a communication medium among it. And a bus is a set of wires and communications protocol. Bus protocol determines how devices should communicate. Devices on the bus go through sequences of states. Protocols are specified by state machines. One state machine per actor in the protocol may contain asynchronous logic behavior. Next, we're going to discuss about 4-cycle handshake. So, in this, it serves as a bus master and initiates all transfers. If any device could request a transfer, then other devices must be starved of bus bandwidth. As bus master, the CPU reads and writes data and instructions from memory. It also initiates all reads or writes on input-output devices. The basic building block of the most memory bus protocol is the 4-cycle handshake. The handshake ensures when two devices want to communicate, one is ready to transmit and other is ready to receive. The handshake uses a pair of wires dedicated to the handshake, enquiry and acknowledge. Extra wires are used for data transmitted during the handshake. Each step in the handshake is identified by transition on enquiry or acknowledgement. First, device 1 raises its output to signal an inquiry which tells device 2 that it should get ready to listen for data. When a device is ready to receive, it raises its output to signal an acknowledgement. At this point, devices 1 and 2 can transmit or receive. Once the data transfer is complete, the device 2 lowers its output, signaling that it has received the data. After seeing that acknowledge has been released, device 1 lowers its output. Device 1 lowers its output. At the end of handshake, both the handshaking signals are low, just as they were at the start of the handshake. The system has thus returned to its original state in readiness for another handshake-enabled data transfer. The major components of the microprocessor buses are clock, which provides synchronization, and read or write is true when reading. And the next one is address. Address is a bit bundle of address lines. And next one, data. Data is a n-bit bundle of data lines. And data ready signals when n-bit data is ready. Thank you.